Hey everyone, in this video I'm going to go through a step-by-step procedure for building your own Schlieren setup. By the end you will hopefully be able to reproduce an image or video like the one shown here. First I'll go through some basic theory, then I'll show you all the components along with instructions on how to make them or where to buy them, and then we'll get to the setup. I'll be posting links to pretty much everything in the video description, so if you hear something that I say and you don't know where to find it or you don't know how to look it up, just check in the video description. Everything should be there. If there's something that's not there, just let me know. Alright, so here's a brief description, a very brief description of what's happening. I have all the materials laid out on the board here. The first thing you need is an LED point source. You want it to be bright and you want it to be as small as possible. You also want a spherical concave mirror with a long focal length. You want an imager or an imaging system, and in this case I use a camera. And you also want a knife edge. In my case I use a razor blade. We also need something to look at, which is this thing right here, and in my case I use a candle. Alright, so let's talk about how this system works. I've taken out the candle in this case so I can show you what happens without that, and then I'll put it back in and show you what happens with it. So we have our LED point source here, and it emits light. It hits a spherical concave mirror, and if you've placed the light source 2 times the focal length away from the mirror surface, it will focus back down to an image of your light source, or a small dot. And so without anything in the path, it'll focus back down there, and then it'll go into your camera. And then what I've added in here is this knife edge where, again, if there's nothing in the path, like nothing to change where the light rays are going, it will again focus back down and then go into your camera, and you should see a uniform distribution of light on your mirror, and that depends on the quality of your mirror. But the problem is, or not the problem, the great thing is that when you add something into the path length here, the light rays will get refracted through it, and what will happen is you'll get some of the light rays that are refracted each way. Some of them might get refracted this way, some of them might get refracted this way down here, and what happens is when they come back this way, some of them might have been refracted so that they will go past the knife edge here, or go past the knife edge here into the camera, and then others will be blocked, depending on how they come off the mirror. I'm drawing them a little skewed right now, but they'll get blocked by the knife edge. So what you get is are essentially shadows where the refracted light is getting blocked by the knife edge, and you get light coming into your camera where it has not been blocked by your knife edge. So that's why you see in these Schlieren pictures, you see some dark areas and you see some light areas, and that depends on how the material that you put in between your light source and your camera is refracting the light. So you've probably seen Schlieren images of, in this case, candles or hair dryers, or even gases with different densities than air, and lots of times you'll see shocks from supersonic or hypersonic vehicles. So it's a great way to visualize. In this case, for this particular setup, you are visualizing the index of refraction gradients in this flow. Source for the experiment, and it's key that it is bright and it is small. So what I use is a white LED. You could potentially use any other light source, such as a light bulb or a flash from or an external flash from a camera. But I choose to use an LED because it's a simple circuit to just rig up, but I have used other light sources in the past. The LED circuit you can see here with this battery mount, this 9-volt battery attachment here, is just a simple white LED that I bought at Radio Shack, and a 470 ohm resistor, so that's the yellow, violet, brown, gold. The LED, the resistor, and the battery attachment are all soldered together on this prefabricated circuit board that I also bought from Radio Shack, and that I split into a small size like this so that it's convenient for this experiment. The light source, a point source, or as close to a point source as we can get, I added this mask onto the LED that I've made, and the way that I did this was just to take this piece here, which is a piece of aluminum foil, or tin foil, and I took a tiny piece and I wrapped it around the LED like that, put it on top of it, and then I poked a little hole with a pin, which gives me that pinpoint, and then I attached that on, so I can just do that. So I just have this piece of aluminum foil on top of the LED, and then I took a piece of black paper, construction paper, cut a hole the size of the diameter of the LED, and then I put that over it, and that way we don't have any of this extra light that's reflecting off of the circuit board or off of the other components or around the light. Buy is arguably the most important part of the setup for quality of your images or videos. So I bought this spherical concave mirror off of Anchor Optics, which is a cheaper version of Edmund Optics. I got the mirror that is about 3 inches in diameter, and the focal length is about 30 inches. And since you need to place the mirror 2 times the focal distance away from your light source and knife edge, you need about 60 inches. So just something to take into account when you're buying your mirror is how big or how long the focal length is, and so that'll tell you how much room you'll need for your setup. So this is where I got my mirror from. So if you go to anchoroptics.com, and then you go to commercial grade optics, and then we go to commercial grade mirrors, and then down here we go to commercial grade large concave spherical mirrors. Brings you to this page, and you can see that there are 4 different options here. And if you look at this table here, you see the diameter in millimeters, the thickness in millimeters, the focal length in millimeters, and the price. And so the one that I got was this 75 millimeter, which is approximately 3 inches in diameter, focal length of 750 millimeters, which is approximately 30 inches in length, and then the price of this one was $20.50. So the mirror actually wasn't too expensive. You could get a mirror that is approximately 6 inches in diameter that has a focal length that's double the focal length of the one that I had, but that one costs an extra $55. So it's really depending on how much you want to pay for your mirror, but this one worked perfectly fine. If I had the option to do it again, I probably would have purchased a longer mirror, and I might do that in the future. In terms of sensitivity of your setup, you actually want a longer focal length for the mirror that you buy, because that'll give these rays that are diverted or refracted from the medium that you've passed the light through. They'll have more time to diverge from the focus point, from where all those rays of light come into the focus that haven't been disturbed. So a longer focal length of your mirror will give you a higher sensitivity, but that doesn't mean that you can't use a lower focal length mirror and you'll just have a little bit less sensitivity in your pictures and videos. You need somewhere to mount your mirrors, so instead of buying one offline that can cost a lot of money from one of these optics companies, I decided to make mine out of cardboard, which you can see here. The most important part is this circular piece here that actually mounts the mirror, which I made out of a thin sliver of cardboard. So if you take the mirror that you have, and I took a thin slice of cardboard that wraps around and overlaps upon itself, then you can wrap it around snug but not too tight. Wrap it over itself, take a piece of tape and just tape it to itself, and then once you have that, then you can tape it all around to whatever mount you have. And in this case I just took essentially a triangular piece of cardboard like this. And now when I fit this in here, when I fit the mirror in, you can see that it has a nice snug fit in there, but still easy enough to get out. An important part of the mount is that you have this piece in front here, because if you didn't have this, if you just had this V right here with the mirror mounted here, you can see that the pivot point on the bottom here is the mirror actually sits out in front of the pivot, which means that this mount will tip forward. So this is nice to have this piece out here. It's convenient to have so you can put your candle on here or whatever you're looking at, and it's also nice so that you can put a shim underneath here to prop it up if you want to change your angle. The edge that I used in the experiment is simply a razor blade that I bought from Walmart or Target. I bought a pack that had like 3 of these boxes, which comes with a ton of razor blades. I really only just need one, but the point is that they're super cheap. Here we have all the materials that we need to get started. You can see I have my phone, I have the LED light here, little circuit that I made with an attachment for the battery, a 9-volt battery, the mask that I'm going to be putting over the LED, the knife edge razor that I'm using, this block of wood which will be helpful for attaching to the tripod. I got a little bit of extra tape here, a little shim that I'm going to be using for adjusting this mirror, and you can see the mirror right here in my cardboard mirror mount. And then I also have the candle that I'll be using. So first I'm going to move the materials to their positions on the table, just in general. So I'm going to take my mirror and the mirror mount, put it over here with the candle over here, the shim that we're going to use to prop this up to get the right angle because my tripod only goes so low, and this table's a little bit low. Over here I have my other tripod here, and over here we're going to be using these items with this block of wood. I'll be finding the 2 times the focal length with my phone and the flashlight on it. Okay, so the first thing I want to do over here is take some masking tape, like this. And I want to attach my LED to this piece of wood. You can also use cardboard, doesn't really matter. This is just to hold it on here. So I'll just tape it on like this. And now we have it on here like that. Now I'm going to take my tripod here. I have the wood block with the LED attached to it, and I just want to tape this on here so that we get a little bit of movement range for this LED when we're trying to align it. So I'm just going to take a couple pieces of masking tape here, and I'm just going to attach it like this, and like this, and then I'll attach one on the back, which you can't see, but you'll have to take my word for it. So now we're all attached on here, so I can have a little bit of movement here with this tripod. I'm also going to connect my battery at this point. So connecting the battery, and I'll put it in the back of the tripod like that. Okay, so now we have our LED mounted like this. I'm not going to put on the this yet because this will help us in finding the reflected light coming back here, so we'll be able to use it to find the beam spot coming back here. Another thing that you can do now is take the razor blade, and we want the beam to be coming back almost right on top of the actual light source here. So I'm going to take the razor blade and I'm just going to stick it. We don't want to short out the circuit, of course, which we're doing, but I'm going to stick it in there like this. And now when the beam spot comes back on this light, or near the light, it'll hit the razor edge right there and go back into the camera when we align that in a second. Okay, so now I have that all set up. So I set up the camera sort of at the behind the setup, so you can see over here is our mirror, and that bright spot up there is the LED that's turned on right now. It's in a rough position, but I need to find out where to actually put it, so I'm going to use the flashlight app on my phone to find this. So I'm just going to put it right here facing the mirror. So facing the mirror, you can see that there's a reflected spot on it. I'm just going to keep backing up while keeping the spot on my phone. And you can see right now the spot, it's getting, I don't know if you can still see that on the video, but it's getting smaller and smaller until eventually it hits the focus point and then back out again. So we know that the 2 times the focal point is right here, or 2 times the focal distance is right here. Okay, I've set this up at a different angle, but now I'm going to bring back the phone again, and you should see the dot on there up by my hand. I'm going to keep bringing it back. Now it's getting bigger again. Bring it back forward, it's smaller. So, but you can see that it's a little bit low right now compared to, this is the minimum height that I have on this tripod, so I actually need to bring the spot up a little bit, which is why I'm going to use the shim on my underneath the mirror mount. So I've just pushed that piece of wood, or that coaster, a little bit farther under it to bring the angle up of the mirror, and I'm going to do this again. And now you can see that it's at actually a pretty good height right here. Just want to make sure you can see it. Now it's almost at the height of the laser over here, so I think that we're at a good point to start using the LED, or not the laser, the LED to align this system now. And that's where we're going to use this black cover here to find the spot. And actually, right now, you can see, I can see this is the spot from the LED right here. So we need to do a little bit of adjustments because it's not in the right spot, because the laser spot right here, the focus, where the point, where the laser, or where the LED light becomes the smallest, should also be right next to here. Okay, I've zoomed in a little bit on the LED light. I'm going to use the mask now to find the optimum point. You can see back here gets blurry. We move it back towards here, we get a sharper image. It gets blurry again. So we're actually at about the right distance away, but I want this spot to be on the razor or the knife edge. So I'm just going to move the I'm going to move this over a little bit, and you can see now we're kind of in towards the right position. And then what I can do now to get a smaller spot is add the mask on that I made before, like that. And now you can see on the knife edge right there, that's where our spot is. It's at approximately the same height as the actual LED. And now we can actually set up our camera, the camera that I'm filming on right now. Alright, so here's an overview of the setup. You can see over there is our mirror. Down here is the knife edge. The LED is on the front of this piece of wood that's taped to this tripod, this first tripod. And then I have my other tripod right here. And this is what I'm going to be attaching this camera to. So I'll do that while I'm filming. So I'm just going to put this in here, snap it in. Okay, and now you can see that we can do some fine tune adjustments here using the height and the rotation of the camera. So I'm going to adjust my camera on the tripod. I'm going to move it down a little bit, and you can see there we can see this bright light from the LED, and I'm just kind of adjusting just on the fly here just to see if I can get something that looks nice. And now I'm going to zoom in and focus on the mirror that I have up there. And something that I'm going to do now is you can see it getting darker. I'm adjusting the exposure compensation on the camera, and then I'm adjusting the focus again. And I am also now, you can see that shifting a little bit, I'm adjusting the tripod that's holding the knife edge. And now I'm going to put in this candle. Now I need my matches, and I'm going to put the candle in. So I'm going to light it. You can probably see my hand right now. Okay. Okay, so now the candle is lit, and now I'm back at the camera, and let's see what's happening. Okay, so you can actually see, you can kind of see the flame right now, not the actual flame, but you can see the flame as there's a little bit of orange down at the bottom of the mirror, and now we can adjust the camera back and forth until we get something that looks kind of nice. Here I've adjusted a little bit more, just some fine-tuned adjustments from the front, and let me just blow over the candle from back here. Hopefully it moves. There you go. You can see it moving, and this is actually a really crisp picture here. It's blowing a little bit to the left right now, but now the flame's coming back in. Let me move the candle over to the right. You'll be able to see it moving. You'll be able to see me pushing the candle over a little bit, as long as the light doesn't, as long as I don't change too much of where the mirror is placed. So you can probably see me pushing that. You might even see it shaking when I'm walking, because when I'm walking, even though this is a hardwood floor, this is me tapping my foot, and you can see that it's shaking a little bit. But this is a really nice, crisp picture. And again, this is with the exposure compensation down to -5 on my Nikon D3200 DSLR camera. I have I'm at f13 right now. I'm taking this video. My ISO is 100. See what happens again here. It's flickering. You can actually see the candle, so you know that it's not the flame. It is in fact those density gradients. So now I'm just going to change the exposure compensation again, so you can see what I was talking about. I'm zoomed in as far as I can go, and then I manually adjusted the focus. So here I'm going to take the exposure compensation. It's at -5 right now, and I'm just going to start clicking it up. I'm at -3, -2, -1,
Now I'm at normal, and then I'll just keep going all the way up to +5. Not that it really matters, but you can see it's just oversaturated there. So the key is to get it down to the smallest amount that you can. So now I'm back down at -5, and we can see that nice crisp picture again.
In this video, I switched out the nice commercial grade mirror for this quote-unquote consumer grade mirror. It's clear that this quality has decreased quite a bit, and it's mainly due to the non-uniformity of the mirror surface. This non-uniformity means that the beam spot doesn't come back to a point at 2 times the focal distance as shown in the inset video. Here I'm moving my light source, or my phone, closer and farther away from the mirror so you can see how the spot changes. You can see that it never gets down to a small spot like the LED. This is partly because I'm using my phone's flashlight, which has a bigger area than the masked LED, but it doesn't even focus down to the image of the flashlight as it should. So thanks for watching this at-home do-it-yourself Schlieren setup video. If you have any questions or comments, you can put them in the comment section on this YouTube video, or you can send me an email or private message me. Thanks again for watching.